What makes a planet habitable? The right distance from the sun? The presence of liquid water or an atmosphere? All of that is important, but scientists are increasingly coming to a staggering conclusion. The decisive factor might be something as simple as its rotation around its own axis. What happens if a planet starts spinning too slowly? It turns into a true cosmic hell. Today on Shocking Space, we are going to uncover the mystery of how slow rotation kills entire worlds, why Venus turned into a scorching oven, and whether such a fate threatens our own Earth. Fasten your seatbelts. Imagine that a planet's rotation is its built-in thermal regulation and security system. When a planet spins quickly, like our Earth with its 24-hour cycle, two critical mechanisms are at work. The first is the Coriolis effect, which chops up atmospheric currents, creating stable winds and cyclones that evenly distribute heat. The second is the magnetic dynamo, where the movement of the liquid core driven by rotation generates a powerful magnetic field that shields the atmosphere from the deadly solar wind. But if you slow a planet down, this fragile system collapses instantly. And most horrific example of this is Venus. In size and composition, it is almost a twin of Earth, but its rotation is a complete anomaly. A day on Venus lasts a staggering 243 Earth days. It rotates around its axis slower than it completes one orbit around the Sun. The result has been catastrophic. Due to its slow rotation, Venus's core fails to generate a full-fledged magnetic field, and the solar winds spend billions of years evaporating water from its atmosphere. At the same time, a runaway greenhouse effect occurred. One side of the planet fries under direct sunlight for months while the other remains in prolonged darkness, sparking superrotation of the atmosphere. Hurricane-force winds drive dense carbon dioxide clouds, trapping all the heat inside. The bottom line? A temperature of 470 degrees Celsius and a pressure that would crush a submarine in seconds. A similar fate has befallen other worlds. Mercury, for example, makes one rotation every 58 days, causing its daytime side to heat up to plus 430 degrees Celsius while its nighttime side plunges to minus 180 degrees Celsius, a temperature swing of over 600 degrees. But the most fascinating things await us beyond the solar system. Most potentially habitable exoplanets orbit red dwarfs and are in tidal locking, meaning they are always locked with the exact same side facing their star. On one side of such a planet reigns an eternal scorching day, on the other an eternal freezing night, and right along the Terminator line between them rage supersonic winds capable of tearing any atmosphere apart. Now imagine for a moment, what if Earth's rotation suddenly slowed down to just one rotation per month? Our magnetic shield would fade, and solar radiation would scorch the surface. A single day would last 2 weeks, during which temperatures would climb to plus 80 degrees Celsius. And over the following 2 weeks of continuous night, everything would freeze down to minus 100 degrees Celsius. The oceans would shift their boundaries, and atmospheric winds would simply sweep away everything humanity has ever built. So, the next time you complain that a day is too short and you don't have enough time to get things done, thank our planet. It is precisely these 24 hours of dynamic rotation that grant us a mild climate, a breathable atmosphere, and reliable protection from cosmic chaos. And what do you think? Will humanity ever be able to colonize slow-spinning worlds like Venus or such exoplanets? Share your thoughts in the comments. Subscribe to the Shocking Space channel, hit the like button, and ring the bell so you don't miss new cosmic discoveries. Thanks for watching, and remember, the universe still holds countless astonishing mysteries. See you.